Why would a team of scientists travel to the interior of Greenland and drill through 2 miles of ice sheet to study the history of the ice?
In 2017, I joined a team headed to Greenland to collect cores whose properties encode how the ice had changed in the past. From just one location, we learned so much about this vast expanse and its history. For example, when was this area, today covered by 2 miles of ice, last ice-free? Answering this question can help us predict how quickly future sea levels will rise. But from here, in a lab built 50 feet beneath the surface of the snow, holding a solid tube of ice some 2 feet long and 4 inches across, thoughts of sea level rise and hurricane impacts are far away. How does one begin to express the scope and scale of glacial history that we learn from these samples, and the deep sense of awe that comes to me when I read the ice sheet's history in my scientific studies of these archives? As a scientist interested in art, this collaboration provided a means.
Although artists and scientists often work together for a visual rendering of scientific concepts, or to tap science as a source for art, here we have set out to construct work that is neither science nor art but a hybrid, seeking to provide value to both disciplines. With this in mind, we set aside our scientist and artist hats, opening the door for us both to contribute throughout all phases of the project, from selecting the science topic through idea generation and on to its physical construction and presentation.
There have been 5 significant advancements in the methods used to study the history of Greenland's ice sheet. The 5 columns represent the 5 methods used by scientists to interview the ice. They span examining marine sediment cores, offshore seismic data, sediments below and within the ice sheet, and peering into the layers within the ice itself. Each of these archives, whose recovery has been enabled by advances in technology and logistics, has enabled reconstruction of the ice sheet configurations from the past. The first column represents cores drilled in the sediment off the coast of Greenland, and marine sediments exposed in North Greenland that contain seeds and deposits with preserved DNA of willow and larch trees, as well as mammoth and hare living on Greenland millions of years ago. Seismic data, shown in column 2, enable scientists to peer into the sediment below the ocean floor. The layers and densities of sediment tell us that the ice sheet has been much larger than today many times in Earth's history. Column 3 references ice cores drilled in the 1960s that provide a continuous record of Greenland's ice sheet history. Just as tree rings tell us about climate conditions over the life of a tree, the ice layers record the conditions of Greenland's ice sheet since its formation. Column 4 speaks of data collected from airplane-mounted ice-penetrating radar. This type of data enables scientists to map ice loss, as well as see bodies of ice that have persisted for the last 125,000 years, a time when the Earth had periods warmer than today. Layered on top of this history, the visualizations shown in column 5 show the rapid changes recorded by today's satellites, specifically the increasing rate of ice melt from 2002 to 2023. Taken together, these columns tell us that in climates not much different than today's, the ice sheet has been much smaller. What we do not yet know is exactly what our future holds, but we know that human activity is accelerating changes.
The rapid transformation of Greenland's ice sheets will impact coastal communities across the globe. Interviews addresses this concern via a multimodal art installation consisting of 5 collages sourced from scientific methods mentioned. Accompanying the collages are glass and clay physicalizations of Greenland's ice sheet coverage, reconstructed with the help of models from the interview methods discussed. While focusing on the specifics of Benjamin's research, we hope to open a conversation on the evolutionary nature of scientific inquiry, the depth of thought and effort scientists devote to understanding our planet and its future, contributing to the trust in scientific findings, as well as providing an entry point for an embodied connection to these remote regions of our planet.